Alright, so we have lesson 11.4, and we are applying the Pythagorean theorem. Now, Pythagorean theorem is probably one of the more useful theorems that you will come across because you will have to apply this theorem in geometry, in trigonometry, and other forms of mathematics once you go through different math courses. So it's a very useful theorem, and here's what it means. The Pythagorean theorem is if a triangle is a right triangle, which means that one of the angles is at 90 degrees, then the sum of the squares the lengths of the legs equal the square of the length of the hypotenuse. So if I look at this triangle here, the legs are represented as A and represented as B. Those are the measurements of the legs. And C is represented as the measurement of the hypotenuse. So your formula for the Pythagorean theorem can be written as A squared plus B squared equals C squared. That's where the sum of the squares of the lengths equal the square of the length of the hypotenuse. So you have to remember that when you're applying the Pythagorean theorem, you must make sure that you are taking the sum of the legs and not taking the sum of the hypotenuse. So with that, let's do some examples. So for A, we want to find the unknown length using the Pythagorean theorem. Now, if we look at A and B, we know that it is a right triangle because we have the right angle symbol represented here. And the hypotenuse is always the distance, or always the length that is opposite of the 90-degree angle. So for example A, our hypotenuse is unknown, and for example B, our hypotenuse can be represented as 5. So let's look at A. We know the distance of our two legs, which is 12 feet and 5 feet. So by applying the Pythagorean theorem, which is, A squared plus B squared equals C squared, we can then substitute in our numeric values and solve for the hypotenuse, which is always C squared. Now, it doesn't really matter which leg you choose as A or B. Customarily, or no, what's the word I'm looking for? I guess usually the smallest leg is represented as A squared, and then the larger leg is represented as B squared, and then the hypotenuse is always as C squared. So I'm going to use that same form. So I'm going to use my smallest length as 5 squared plus 12 squared, which equals C squared. So if we square our 5 and our 12, so 5 squared is 25, and 12 squared is 144, and so that's C squared. So now we just do the math. We go 25 plus 44, which is 169. That equals C squared. And in order to find C, we can take the square root both sides, and we can write c as 13. And since we have a label, we can write it as 13 feet. Okay, let's look at B. So B has, we're given one leg and we're given the hypotenuse, but what we don't know is what the other leg of the right triangle is. So have some room here, so I've got a squared plus b squared equals c squared. What I'm going to do is, this is going to be my b. I don't know what b is, so, but I know my a is going to be 3, so I'm going to write 3 squared plus b squared equals, and then this one's going to be, and my hypotenuse here is 5, so we have 5 squared. So I'm going to square these values, so that gives me 9 squared plus b squared equals 25. Now we just do some algebra, so I'm going to subtract both sides by 9. That cancels, which leaves me with b squared equals 16. And if we take the square root of this, we can find that b equals 4 inches. Okay? So, for example, C, they give us a story problem. And the story problem says a right triangle has one leg that is a foot longer than the other leg. The hypotenuse is the square root of 13 feet. Find the unknown lengths. So, I like to draw a picture. So, when it comes to doing right triangles in Pythagorean theorem, let's draw a picture. So I know that this is my right angle, and what they've told us is that the hypotenuse length is the square root of 13. So that is the opposite of the right angle. So this distance here is the square root of 13. And what did they tell us about the length, the two legs? It says that one leg is a foot longer than the other. Well, let me write it. This is square root of 13 feet. So, and they say that one is a foot longer. So I'm going to say that, let's just call this one leg x. And if the other leg is 1 foot longer than that, so that it will be just whatever the distance of this leg is plus 1. And again, we're going to apply the Pythagorean theorem, which is a squared plus b squared equals c squared. So let's make our a squared be, or our a be x plus 1, and then I'm going to square it, plus x, and I'm going to square it, equals the square root of 13 squared. Now we must remember, when you take the square of x plus 1, you have to remember it's like x plus 1 squared is like saying x plus 1 times x plus 1. You can't just write x squared plus 1. That's incorrect. You must FOIL it out, and we get x squared plus 2x plus 1. That's when it's fully FOILed out for x plus 1 quantity squared. And so then I'm going to add my x squared here, and that equals 13, because the square root of 13 squared is just 13. And what I'm going to do, because now I have variables that are squared and variables that are not squared, I'm going to set this equal to 0. So first I'm going to combine like terms. So I got x squared and x squared here, so that leaves me with 2x squared plus 2x plus 1 equals 13. But now I'm going to set it equal to 0, so I'm going to subtract 13 to both sides, which leaves me with 2x squared plus 2x minus 12 equals 0. Now this kind of looks like a quadratic a little bit that we learned in chapters 9 and 10. And what we're going to do is I'm going to see if this factors out. I think it does. So parentheses, parentheses, got an equal sign here. I know that there's a 2x here, and it'll be an x here. And I think there's 6 and 2. And I think this is where the plus is going to be, and that's where the minus is going to be. So if you check your math here, and if you FOIL this out, it should come out as 2x squared plus 2x minus 12. So now we just use the zero product property that we learned in chapter 9. And if we take 2x plus 6, that equals 0. That'll be x equals a negative 3. And the x minus 2, if that equals 0, or your x then would equal 2. So we do have a problem with x equals negative 3 because negative 3 can't be a distance. So we can eliminate that as a possible solution. So our x here would have to equal 2. And if our x equals 2, that means that our other leg then would equal 3. So our unknown lengths for this problem would be 3 inches and 2 inches. And if you weren't sure if you had the correct values for whatever missing legs that you're trying to solve in whatever particular problem, you can always double check by applying the Pythagorean theorem and seeing if those numbers hold true. In this case, it does. Okay. Not only is there the Pythagorean theorem, but there is what is called the converse of the Pythagorean theorem. It states that if a triangle has sides lengths a, b, and c, such that a squared plus b squared equals c squared, then the triangle is a right triangle. So what that means is in these examples that you're going to be given, 3 measurements. And what we have to do is figure out whether those combinations of those 3 lengths can make up a right triangle. And we can do that by using Pythagorean theorem. So let's look at A here. So I have A, and I have lengths of 7, 23, and 24. So here's to keep this in mind anytime you're trying to use the converse of the Pythagorean theorem and you're given 3 measurements. The largest measurement is always the hypotenuse. So that'll always be your C. So for A, my C will always be, my C is going to be 24. For my B, my C is going to be 13 because those are the largest numbers. Now, it doesn't matter. Once you find that largest number, it really doesn't matter which one you have as your A or B because they're on that one side of the equal sign and addition is commutative. So, but I'm just going to, I always like to use the smallest one as my A and then the middle as your B. And so, same thing here. And again, now let's apply the Pythagorean theorem and see if these measurements hold true. So I have 7 and 23 and 24. So I need to do is I need to figure out if 7 squared plus 23 squared equals 24 squared. That's the goal. So what I'm going to do is let's just look at the left-hand side of the equal sign first. So 7 squared is 49, and 23 squared comes out to 529. And if I were to take 49 and add it to 529. That gives me a total of 578. Now what I need to do is I need to see if 24 squared equals 578. And 24 squared comes out to be 576. So I can determine that 578 does not equal 576. So for A, this would be, this is not a right triangle, so I would just put no. It cannot work. For B, we're going to do the same thing. So I want to determine to see if 5 squared plus 12 squared equals 13 squared. So again, we're going to use the same thing. I'm going to try to find the left-hand side. So I got 25 plus 144. And if you add those together, it gives you 169. And 13 squared ends up equaling 169. So 169 does equal 169. So 5, 12, and 13 do hold true. Those are called Pythagorean triples. And I would write down yes. This is a right triangle. And that is how you apply using the Pythagorean theorem to find distances of right triangles, and also using its converse. And I hope this helps. Until next time.